Okay, lesson 16, types of variables and data sets. This is going to be a short one. We're just going to show you how we like to set up data sets. We a lot of times they'll be saved as CSV files. People put them in Excel a lot, but we have a certain structure that we like to have our data sets in. So structure of a data set. So this is just a probably cheesy reminder, like columns, they run up and down vertically, rows go horizontally. So when you have it, there are a lot of variables that you can collect on an individual. So each row in a data set is going to correspond to one individual or case that you're collecting on. So if we were looking at the machines and the rubber seals and the tensile strength, each individual rubber seal would get its own row. That's the idea. So each row is going to correspond to an individual that we collect information on. Each column is going to be a variable that we measure, although a lot of times data sets will have a column in particular that uniquely identifies individuals. This could be like student ID number, this could be phone numbers. These are subject identifiers. They're not actually a variable like of interest that we're looking at analyzing, but they are useful because they let us know how many unique individuals are in the data set. It does make sure that, oh, I didn't, record Joe twice, that kind of thing. And it is important because it's very, very easy to accidentally double dip and count people more than one time. And you don't want to do that. And we'll have a data set and we'll show you. But so individuals, data, and variables. So an individual or case is an object described by data. So this will be like those observational units here. And you can collect information, characteristics about them. We'll call those variables. And the data set, it's a collection. It's the set of individuals and the variables collected on them. So there are going to be two main variable types that we look at. I hinted at them a tiny bit earlier when we were looking at discrete versus continuous random variables. So categorical, this is where you are recording a quality that is assigned to a category. So right or left-handed, that kind of thing. So right versus left-handed. You might want to add other options like ambidextrous or whatever that group that might be interested in. Manufacturer, if you're looking at different machines, for sure. Eye color, political party, it goes on and on. There are a lot of things you can look at for categorical variables. Quantitative, so you're looking at a quantity here. So this will be numeric. Almost always, so not only will it be a numeric, it'll be a number that would make sense to average if you wanted, or to average. So examples, tensile strength. Speed, height, length, distance, density, volume, all sorts of, these would be all quantitative. One exception that I want to put here is it is numeric, but it's not a quantitative variable, would be zip code. And I'm not saying that you need to have this one memorized, but just know that there are exceptions to the rules. But like zip codes, it's numeric. However, the numbers correspond to a category. You wouldn't make sense to average zip codes together. It wouldn't make sense. So just know that for the most part, if it's numeric and it makes sense to take an average of them ever, it's going to be a quantitative variable. And in general, categorical variables, and it could be like political party where there's numerous categories, or it could be are you left-handed? Yes or no. A lot of them are divided into yes or no. That'll be categorical. And not only that, we're going to be using these ideas to help us determine how we describe the data, like what summary statistics do we use for them, and what plots do we use to describe them. So here we have an example. It's a data set, a rigorous engineering course. They make their students take an entrance exam to get into the course. Seems kind of mean, right? You already had to get into college. You already had to make the prereqs, but yeah, here, take this exam to take this course. Great. So here's our data set. Here they defined what each of the variables are, which is nice. It's very handy when they include a legend. I believe we now posted the ST314 student survey data set, and it does have a similar key where it tells you the variable name and what that variable name stands for. So if you look at rows, there are 5 different students that we went ahead and collected data on. They're easy to count, especially because of this individual. So this is the subject identifier. Not that it's super important. It's more of acknowledging that individual is not a variable I'm interested in analyzing. It is useful because it tells me I have 5 unique individuals. I have individual 1, individual 2. I know that they aren't the same individual. A lot of the times there's something like, they could be people's full names or even partial names. They could be ID numbers. Could be student ID. It could be state ID. It could be all sorts of IDs. Depends on the data set. Could be even social security. Hopefully not. But and then it totally depends. Then all of these columns here, exam score, GPA, gender, year, these are all variables that were collected on each of the 5 individuals. And just some commentary. It says gender here. Know that, unfortunately, the field of statistics, or just research in general, has a nasty tendency to treat sex and gender as interchangeable, and they're not. But so just keep in mind, just a critical lens there, that you might have very limited responses because a lot of times these surveys, they only allow 2 options. And gender and sex are not interchangeable. So if I wanted to break down these variables to look at, exam score, they're numeric, and it would make sense to take an average of. So this will be a quantitative variable. Then I have GPA, which is numeric as well. And it would make sense to take an average GPA, so that'll also be quantitative. If I look at the gender variable, you see male, female. The second you see things that aren't numbers, most of the time this is a good indicator. It's going to be categorical. Oops. So this is going to be categorical. I'm going to write cat. And then year. Junior, senior, sophomore, junior. Once again, these are not numeric. It would not make sense to average them, so I'm going to go with categorical. So that would be a breakdown of this very basic small data set